So now we return to calculating volumes for three-dimensional solids. We already looked at the volume of a cylinder, and we discovered that a cylinder is in fact a prism. So it was as simple as finding the area of the base of the cylinder and then multiplying it by the height. Now we've got two other solids over here. Can you decide which one of these is a prism? Well, the answer is the one on the left, this tent type shape. It's a bit like a tent. It's a pretty small one with those measurements, but I'm sure you get what I mean. Now, let's see, why is this a prism? Well, if we were to look at this shape here, we see that this repeats throughout this three-dimensional solid. See how we get that repeating shape? If we were to cut or slice downwards anywhere along here, we get this same shape and size triangle all the way along. All right? That's a repeating cross-section. And that means that this is a prism. Now with the sphere, that's not the case, because if we cut, well, that's not very good, but imagine if you just sliced the very top off an orange, you'd get a smaller circle up near the top, and if it was down near the middle, or through the center of the sphere, you'd get a bigger circle. So although this is the same shape, we're getting circles as we cut this way, they're different size. They're a different size from one another, so not a prism. Right, so that means that for this tent shape on the left, we need to find the area of the base and multiply it by the height. So I'm going to find the area of this triangular shape. Now I'm calling it the base. Normally we think, well, the base of a shape means it sits on the ground. Well, it doesn't necessarily always work out that way with these three-dimensional solids. We're going to find the area of this triangular base. And I know it's not sitting on the ground, but that's the base of this prism, because that's the side where the repeating cross-section continues through the three-dimensional solid. Now you might feel confident enough to pause the video and continue from here by finding the area of this base and multiplying by the height. Then I'll have a go at it. Okay, I'm going to do it now. So the volume, we have a prism here, so area of base times height. Okay, so the area of the base is a half times the base length, 3.2. That's confusing, isn't it? This base has a base length. Well, the length along the bottom here, and perpendicular to that we have a height of 2.8 centimeters. So that's a little confusing, because I'm talking about the height and the base area of this prism, but at the same time I'm talking about this triangular shaped base with its own base length, which is 3.2, and a height of 2.8. So consider these are separate. These 3.2 is the base length of our triangular base, and the height of our triangular base is 2.8 centimeters, and then separate to that is height of the prism, which is 4.7 centimeters. If you're confused, get me over to have a chat about it. Maybe I didn't word that very well. Now I'm just going to change the color on the height. Here we're talking about the height of the prism, not the height of the triangular base, and that's our height along this side. So the height there, so multiplying this by 4.7. So just to reiterate, area of the triangle is this bit in blue on the left. a half times the base length of the triangle times the height of the triangle. That gives us the area of the base of the prism, and we multiply that by the height of the prism. And what does that give us? Well, you might want to try this one on the calculator. I'm doing it now. Okay, so half times 3.2 times 2.8 times 4.7. The volume is 21.056, and we've got cubic centimetres. So 21.056 cc's. Okay, so there's the volume of that prism. So let's look at the volume of the sphere. Now the sphere is not a prism, so we're going to use this formula back here. Keep going back to this page. Here it is here. The volume of a sphere. Let me just see if I can get that to go up a little bit. It's not playing ball. There we go. Here it is here. Volume 4/3 pi r cubed. So this is the first time we've seen a power of 3, this cubic, in an equation. And it might be a little tricky getting that 4/3 into your calculator too. 4/3. So if you're not sure about how to do that, make sure you consult with me. But you could give it a go and see if you can get it to work. So the formula is, volume for a sphere is 4/3 times pi times r cubed, r to the power of 3. So there's a couple of things that might be tricky to put into the calculator. See if you can get it to work. So 4/3 times pi, now times the radius, which is 1.6 to the power of 3. Okay, so I'm going to put that into the calculator now. Remember, if you're not sure how to do it, get me to show you. And the number we should get is 17.16 cubic centimetres. So there are our two answers for those ones. Okay, so go ahead and try some of the questions that are assigned in the textbook.